Welcome to the Ambassador tutorial. In our class today, we are going to be solving a question on exponential indices. Firstly, what is exponential indices? Exponential indices is expressing indices in form of quadratic equation. That's as simple as that. So let's solve a question on this. Coming down to the board, we have that solve the equation in which we are given 3 in the power of 2x minus 3 minus 4 in bracket 3 in the power of x minus 2 closing the bracket plus 1 equals to 0. Now, if you look at this question, how would you know is an exponential indices? There's something common about exponential indices. And what is that? If you look closely, I have 3 in the power of 2x and also I have 3x in the power of 3 in the power of x minus 2. So what does that mean? It meant that there is something related to this and this. So anytime you see something like this, it means you can write it in form of exponential. So how do we write an indices equation or an indicator equation in exponential? Now look at this carefully. Recap, in indices, we usually have what we call multiplication order. That says if I should have the same base, probably I have a in the power of b multiplied by the same a in the power of c. What I need to do is to find a way to add the power because they are having the same base. You are going to add the power anytime you are multiplying. So that means this thing can also be separated to turn back to this. And that's what I'm going to apply to what I have here. So how can I solve this? Solution. At this side, I have my 3 in the power of 2x minus 3. So this 3 in the power of 2x minus 3 can be written as 2x multiplied by 3 minus 3. As you can see, I've actually separated them. If I try to add them up together, I'm going to arrive back to this. The same thing I'm going to apply to what I have over there. I'm going to have 3 in the power of x, the same thing multiplied by 3 minus 2. Same applicable here. When I try to multiply the base and add the power, I'm going to arrive back at the same answer, at the same result I have here. I have it as plus 1 equals to 0. Now, what is fishing out? We have 3 in the power of 2x and also we have 3 in the power of x. There's something we can do to this that is going to look alike with this. And what is that? I can write it by saying 3 in the power of x, closing the bracket, 2, multiply by 3 in the power of minus 3, then we have 4, then 3 in the power of x, multiply by 3 in the power of minus 2, plus 1 equals to 0. Now, if you look at this carefully, we are having 3 in the power of x, 3 in the power of x. So anytime we get to this junction, you have to assume that the 3 in the power of x should be a particular letter. So let's assume that the 3 in the power of x is equals to a. That means any place I have my 3 in the power of x, I'm going to input what? A. So let's try that. So I have 3 in the power of x here. I'm going to have it as what? A square multiplied by 3 in the power of minus 3, then minus 4 in bracket a multiplied by 3 in the power of minus 2, then I have it as plus 1 equals to 0. So in this case, I have actually converted my 3 in the power of x equals to a. So as you can see on the board, any place I have 3 in the power of x, they have literally turned to a. So the next thing is to simplify until it looks like a quadratic equation. So let's look at this carefully. This can be written as a squared multiplied by 1 over 3 in the power of 3. This is inverse law in indices. That is, if I should have a in the power of minus 1, is going to be written as 1 over a. And that's what I apply here, inverse law. So that's what I did. So when I apply inverse law, I'm going to have it as what? Minus 4a times the same applicable here, 1 over 3 in the power of 2 plus 1 equals to 0. So if you look at this, 3 in the power of 3 is 27. So that's a squared multiplied by 1 over 27 minus 4 in bracket a times 1 over 9, because 3 in the power of 2 is 9, then plus 1 equals to 0. So if you look at this carefully, I can multiply a squared by 1. That's a squared over 27 minus 4 in the bracket of, when I try to multiply a by 1 at the numerator, that's a over 9. Then we have plus 1 equal to 0. So what this C is going on, this 4 can multiply the a. That means I'm going to have a squared over 27 minus 4a over 9 plus 1 equal to 0. Now it's seeming as though it's looking like a quadratic, but we need to find a way we simplify 27. And how can we do that? The way we can do it is to find the LCM in each of the fraction or in each of the terms and multiply all through by the LCM. So the LCM here is 27. And when I multiply all through by 27, I'm going to have that 27 in the bracket of a squared 27, then minus 27 in the bracket of 4a minus 9, the same thing, plus 1 equals to 0. So 27 cancel out 27, 9, oh sorry, a mistake here. Here should also be 27, pardon me for that. The here should also be 27 because we're multiplying all through by 27. So 9 here is 1, 9 here is 3. So what will I have on the long run? That's a squared minus 3 in the bracket of 4a plus 27 equals to, when you multiply 27 by 0, it's going to give you 0. So in that case, we can say 3 times 4a, and that will give us 12. So that's a squared minus 12a plus 27 equals to 0. Now looking at this very closely, it's seeming like a quadratic equation. How? There's a general format for quadratic equation. General format, which is ax squared plus bs plus c equals to 0, where your a, b, and c are integers. So we look at this carefully. This my a squared is representing s squared, this my a is representing x, and this my 27 is representing the constant. So you can say that's the quadratic equation. The next thing is to simplify this your quadratic equation to get the value of a. So how do we do that? We are going to make use of factorization method, using factorization method. When I try to use factorization method, how do I solve that? We have a squared minus 12a plus 27 equals to 0. In factorization method, we usually have the first term multiplied by the last term. So when I try to do that, that means a squared multiplied by the last term, which is 27, and that gives me 27a squared. Now you have to ask yourself just two simple questions by saying, what number will I try to multiply when I find the product of that number? I'm going to have 27. And when I find the sum of that same number, I'm going to have minus 12. And what number do you think is that? That's just simply your minus 9 and minus 3. When I have minus 9 times minus 3, I'm going to have it as plus 27, which is here. And when I have minus 9 plus in bracket minus 3, remember that plus times your minus is also known as minus. And that's what? Minus 9 minus 3, and that's equals to minus 12, which is what we have here. So now that we know the two numbers we are going to input, the next thing to do is to just input the value of minus 9 and minus 3 into the middle term. So let's try to do that. So we have the other time a squared minus 12a plus 27 equal to 0. So when you try to input the value of your minus 9 and minus 3 into the middle term, I'm going to have a squared minus 9a minus 3a plus 27 equal to 0. Then the next thing to do, you group them in 2. So grouping them in 2, I have it as a factor. So what's common in this factor? We have a, then a in a squared is a, A in 9a, we have 9. And what's common in this factor? We have 3. 3 in A, 3a, I am left with A, minus divided by plus, I'm going to have minus. 3 in 27 is 9, then equals to 0. Now, if you look at this carefully, you would have seen that the term at the middle are looking alike. So you pick one of them, then pick one outside. So I have that my A is equals to 3, put that in bracket, then pick one inside the bracket, and equal to 0. Now equate each of them. Say A minus 3 rather equal to 0, or A minus 9 equal to 0. So on the long run, I'm going to have my A to be 3 or my A to be 9. Now, that's not the whole question. That's not the whole question. Remember that our A was representing a particular value. So we have to return back the value to get the value of x. At the long run, we started finding x, not A. Now that we've gotten our A, it's very, very easy to get your x. So how do we get our x? Recall that A was equal to 3 in the power of x. So now that we have our A is equals to 3, or the same A is equals to 9. So any place I have A, I'm going to input 3 in the power of x. So that means I have here as 3 in the power of x because I have A equals to 3, or the same thing here, 3 in the power of x because I have A equals to 9. Now, if you look at this carefully, these are the power of 1. That means my x is equals to 1. They're having the same base. Since they're having the same base, their power are equal. Or for the other one, I can convert this to indices by saying 3 in the power of s is equals to 3 in the power of 2. So now they're having the same base, I can literally say my s is equals to 1, or the same s is equals to 2. Now, this is how you get the value of x by making use of exponential indices.